Okay, here we go. We are going to be graphing in intercept form. This is also known as graphing in factored form. And today is 3/22. So we have already learned at this point how to graph a parabola or quadratic function in standard form. So now we're going to look at how do we graph this in factored form. This is going to require the same 5 specific points. So make sure that you are graphing. You must graph the 5 critical points. So regardless of what form you're in, we are always graphing those 5 points. That includes the X-Intercepts, the Axis of Symmetry, the Vertex, which remember always must be labeled, and the Y-intercept. Whoop, too many E's. Y-inter. What is happening here? Y-intercept. There we go. And then the reflected Y. Okay. So there you have it. That is the refresher of the 5 critical points that we need. So when we talk about something being graphed in intercept form or factored form, that means that we need our polynomial or trinomial factored. Okay, so sometimes it might be given to you and sometimes you might need to work it out. So we're going to go through this to figure out how to solve for each of these. So if I am in factored form, I might have something that looks like this. So I already have here it factored out, and we're going to just work through our list. So the first thing is to solve for those X-intercepts. So when we're solving for the X-intercepts, remember what we're doing is we are using the zero product property in order to figure out what the zeros are, which are the X-intercepts or the roots. So here I would have 0 is equal to negative times x plus 1 times x minus 5. So then I would have here x plus 1 equals 0 and x minus 5 equals 0. Minus 1, x equals negative 1. And here plus 5, x equals 5. So then my intercepts, my X-intercepts are going to be listed here as negative 1, 0 and 5, 0. There are my intercepts. Remember, the intercepts are a point on the graph, and therefore you have to make sure to write them as an ordered pair, right? Point on the graph. So ordered pair is important. Next thing we're going to do is we are going to look at the axis of symmetry. So because we are in factored form, the axis of symmetry uses a different formula. So when I'm in factored form, what I have here is f of x is equal to a times x minus p times x minus q. And really, these variables could be called anything else, right? I've seen it where it's called m and n. It just is showing that it's a different variable, okay? So then what we're going to do is we're going to take our factored form, and in order to solve for the axis of symmetry, we're going to have x is equal to p plus q all over, not a, holy moly, y'all, I'm sorry, all over 2. All over 2. So let's take a look at what that means. If I have f of x is equal to negative times the quantity of x plus 1 times the quantity of x minus 5, then what I'm going to have here is, please keep in mind, this is the part that's going to mess some people up, that in my formula here, oh, my highlighter doesn't work. Is today a Monday or what? Holy moly. This is a subtraction, okay? So when I come down here and I have x plus 1, in order to have a plus 1, that means that my p-value has to be a negative. That's really important to pay attention to. So here I have x is equal to, that's going to be negative 1, plus positive 5. Because again, the subtraction sign is part of my equation, so this is a positive 5. When this sign turned, that's what made it this become the negative 1. All of that over 2. So I have x is equal to 4 over 2, and my x equals 2. And this is my A of S. Axis of symmetry. So again, the A of S formula is going to be different if I am in factored form. So in standard form, we use negative b over 2a. Again, this here is factored form A of S. So a times the quantity of x minus p times the quantity of x minus q. The formula then is ax equals p plus q over 2. So this formula is the second formula that needs to be memorized. So you might want to star that to kind of remind yourself. So A of S is 2. Now what we're going to do after that is we are going to find the vertex. So just like the other problems that we have done in standard form, in order to find the vertex here, I am going to go and I'm going to substitute my x, my A of S, into here. So if I have f of 2 is equal to negative 1 times 2 plus 1 times 2 minus 5. So this makes f of 2 equal to negative 1 times the quantity of 2 plus 1, which makes 3, times the quantity of 2 minus 5, which makes negative 3. So f of 2 is equal to a negative 1 times negative 9. So my f of 2 is equal to a positive 9. So my vertex then would be at the point 2, 9. And then the next thing we need to do is we need to solve for our y-intercept. y-intercept. So anytime I'm solving for a y-intercept, you know, back in course 3, we learned that in order for us to have a y-intercept, our x value must be 0. So what I'm going to do is I'm going to go back to my factored form. You don't need to write this as a -1. I'm just doing that for note-taking purposes, just so you know. So here I am back at my factored form, and I'm going to substitute 0 for x in order to figure out what my y-intercept is. So here I have f of 0, which would equal to -1 times 0 plus 1 times 0 minus 5. So I have f of 0 is equal to -1 times 1 times -5. So this is f of 0 is equal to -1 times -5. So I have f of 0 is equal to 5, and my y-intercept is 0, 5. So that there is my y-intercept. And then what we're going to do is we are going to graph this to practice our graphing skills. If you happen to have printed out yourself some graph paper, I'm going to say that you should feel free to use it. I have made some graph paper available for myself, so it can be a little bit more precise while you are all watching this. So we're going to go back here and we are going to look at the x-intercepts. I have one intercept at -1, 0, and I have another one at 5, 0. So I've plotted those 2 points. My a of s is at a +2. So I'm drawing that invisible a of s on my graph. So I can keep that in mind. My vertex is at 2, 9. So I'm going over to 2 and up to 9. My y-intercept is at 0, 5. So 0, 5, 1, 2, 1, 2. There we go. Now I want to remind everyone while we're looking at graphing this is 2, 9. The original problem was f of x is equal to -x plus 1 times x minus 5. And we need to pay attention to that original problem because out there in front is the negative sign, which lets me know that this is going to be a, like I like to call it, a sad meal. My parabola is opening downward. And so that's just something we need to pay attention to. That way, when you start graphing, you're not confused, like, why do my points not allow me to graph upwards? So now we're going to try to do a nice smooth line through our points here to the best of our ability. Doesn't have to be perfect, but as good as it gets. We're going to have something that looks like this. And then we have graphed in intercept form or factored form. Those are kind of interchangeable. And there you have it. So really, the only difference here is being able to identify the axis of symmetry. Otherwise, all the other steps are pretty much the same. So it's just looking at how do I find the axis of symmetry.